Hello friends, continuing with the topic of modulation in communication systems. Today we come to its fifth part, that is communication systems part 5. In this system we are going to study about wireless communication system using amplitude modulation. So here is the block diagram of wireless communication system in the first step. This diagram is divided into two parts. One is transmitter station, the other one is receiver station. Now look at the transmitter station. First we look at transmitter station. So in transmitter station, here we generate a carrier frequency, which is a radio frequency, and here we have mic which converts audio energy into electrical energy, and this electrical energy is amplified in an audio amplifier. Now this information signal is mounted over carrier in the modulator circuit. After modulation, we have a driver amplifier which raises the level of modulated radio frequency wave, and then it is a power amplifier. Power amplifier raises the current level, that is the power of the signal which is required for radiation through antenna. Okay, so this way the signal is transmitted after mounting over the carrier through antenna, that is unguided medium channel. Now it goes to receiver. Here we have receiver station. The radiated signal is intercepted by antenna at receiving station and is amplified in a radio amplifier. The receiving station has a local oscillator which generates frequency equal to frequency difference between the received frequency through antenna and its own frequency. The difference is IFA. The two frequencies are mixed in a mixer and we get the intermediate frequency, which is amplified in intermediate frequency amplifier. Which is normally 455 kilohertz to 465 kilohertz. This frequency of intermediate frequency amplifier is given to detector for detecting audio signal, and if it is frequency modulated system, then we have a discriminator here. After the signals are detected which were generated at transmitter station before mic, these are applied to input of an audio amplifier to raise its level. Then these are given to power amplifier to drive loudspeaker. Loudspeaker converts electrical energy amplified by power amplifier into audio energy, which we can listen. Okay, so this is how any communication system works. For AM we have a detector, and for FM we have a discriminator. This is the only difference. Rest is same so far as block diagram of wireless communication system is concerned. Okay. Now look carefully at the block diagram of this communication system. This block diagram has two parts. One is the block diagram of transmitting station and the other is block diagram of receiver station. Now first we carefully look at the block diagram of transmitting station. This block diagram has amplifiers, oscillator and a modulator. Now look at the block diagram of receiving station. This also has amplifiers, that is RFA, which is radio frequency amplifier, IFA, intermediate frequency amplifier, audio amplifier, and power amplifier. In addition to amplifier, it has an oscillator, a mixer, and a detector. In a nutshell, we can say the block diagram of communication system contains amplifiers, oscillators, modulator, and a detector. The mixer at the receiving station acts as a demodulator. Okay. Now, amplifiers and oscillators we have studied in the chapter of semiconductor and electronic devices. Here we are going to study about modulator and a detector. Here we are going to study about modulator circuits. Second, amplitude modulator circuits. Two types of modulator we have here. One is base modulator and the other is collector modulator. Now, what is base modulator? Modulating signal is applied at the base of the transistor as shown in the diagram. This is modulating signal which is applied at the base of the transistor. So, we call it as base modulator. Now, we study about base modulator circuit in the first step. Now, modulator circuit using NPN transistor, so far as base modulator is concerned, is shown here. Second, circuit explanation. TR is an NPN transistor in common emitter configuration used as modulator. RB is base bias resistor, VBB is base bias battery, AS is audio source generating modulating signal, EMT is equal to EM max sin omega MT. CS, this is CS. CS is carrier source generating carrier wave, ECT is equal to EC max sin omega CT. VCC is T is coupling transformer. VCC is collector bias battery. Parallel LC circuit is tuned to carrier frequency across which modulated output is taken. So, this is modulated output which is taken across a parallel LC circuit. E mod equal to ECT plus KAEMT and is the modulated output. Okay. A third, working. Base bias is varied according to instantaneous amplitude of modulating signal, which results in amplification of carrier according to the instantaneous amplitude of modulating signal. Now, look at this diagram. Here we have the carrier which is ECT is equal to EC max sin omega CT, and from this side we have a modulating signal EMT is equal to EM max sin omega MT, and this modulating signal is mounted over carrier in the transistor which act as modulator. Now, T is a coupling arrangement across which we take output from the modulator, and this is the modulated output in which amplitude of the carrier is varied in accordance with the instantaneous amplitude of modulating signal, resulting into amplitude modulated wave. This is amplitude modulated wave which is taken across parallel LC circuit and is used further for amplification and raising power and then transmission purpose. Okay. Now B, collector modulator. What is collector modulator? Modulating signal is applied at the collector of the transistor. That's why we call it as collector modulator. Now first, modulator circuit using NPN transistor. Here before you is the modulator circuit using NPN transistor. Second, circuit explanation. TR is an NPN transistor in common emitter configuration used as modulator. RB is base bias resistor, VBB is base bias battery, AS is audio source generating modulating signal, EMT is equal to EM max sin omega MT. CS, this is CS. CS is carrier source generating carrier wave, ECT is equal to EC max sin omega CT. T is coupling transformer, and VCC is collector bias battery. Parallel LC circuit is tuned to carrier frequency across which modulated output is taken. Okay. Since audio signal is applied at the collector, so we call it as collector modulator circuit. Now third, working. Collector bias is varied according to instantaneous amplitude of modulating signal. I repeat, collector bias, this collector bias is varied according to instantaneous amplitude of modulating signal, which results in amplification of the carrier according to the instantaneous amplitude of modulating signal, resulting into amplitude modulated wave, which is taken across parallel LC circuit and is used further for amplification and power raising and then transmission to antenna. And here we have the modulated output, E mod is equal to ECT plus KAEMT. Okay. Assignment 15 continued. Question number 19. Draw a base modulator circuit using NPN transistor in common emitter configuration and explain how amplitude modulation takes place. Question number 20. Draw a collector modulator circuit using NPN transistor in common emitter configuration and explain how amplitude modulation takes place. Okay. Now third, AM detector circuit. Here we have AM detector circuit. At the input of AM detector circuit, we have intermediate frequency amplifier, which has a parallel LC circuit at its output side, which is tuned to intermediate frequency, which is normally between 455 kHz to 465 kHz, and it is applied at the input of diode D, which acts as half wave rectifier denoted as HWR. And at the output of this half wave rectifier, we have parallel RC circuit, which act as a filter. Okay, and finally we have audio output across this part of this resistance R. And let us see how it happens. The output of intermediate frequency amplifier is applied to a detector diode D, which acts as a half wave rectifier. It conducts during positive half at input and does not conduct during negative half at input. As we know from half wave rectifier, this happens. Now positive half is available at output. This is positive half which is available at the output, It contains two components, carrier and audio mounted over it. The carrier is bypassed to ground by capacitor being higher frequency than audio, because we know that XC is equal to 1 by 2 pi FC, that is, the reactance of capacitor is equal to 1 divided by 2 pi into frequency into capacity C. So more is the frequency, lesser is the reactance of the capacitance, and if lesser is the frequency, more is the reactance of the capacitance. So due to this reason, carrier is bypassed to ground, this comes here, and audio passes through resistance. And according to Ohm's law, V is equal to IR, depending upon the current of audio through R, we get the audio output. Therefore, the audio is available across resistor R. It is amplified in AFA. AFA means audio frequency amplifier, and then through PA. PA means power amplifier, which drives the loudspeaker. So then it is given to loudspeaker, LS loudspeaker, for listening. The condition for detection is 1 by FC should be very small as compared to RC, where RC is the time constant of the circuit, that is T is equal to RC. So variable R means it is volume control. Assignment 15 continues. Question number 21. Draw a circuit diagram showing detection of AM signals and explain how AM signals can be detected with its help. Question number 22. Define time constant of the circuit and mention condition of detection to take place. Thank you so much. Next time we will take up frequency modulation. Till then, goodbye and good luck to you.